Now, the fact that global warming is real doesn't say what the causes of global warming are, and that's a further question, which again the Intergovernmental Policy Panel on Climate Change has looked at in this part that has been released of its 5th assessment report, and it thinks that it is extremely likely in its terms that human influence has been the dominant cause of the observed warming since the mid-20th century. So most of that rise that you saw in that chart. Now, it uses these terms, likely, extremely likely, virtually certain. It uses them as semi-technical terms. It has a little definition of each of these terms elsewhere in this summary. And it tells you that by extremely likely, it means 95 to 100% probable. So somewhere in that range. It's the highest term it uses other than virtually certain. So they think that this is extremely likely, and this, as I say, represents the opinions of hundreds of scientists. There are a small number who would question this, but I think if we're looking at the ethics of this question, we can't really claim to resolve with higher certainty than this claim the actual argument about whether human influence, the release of greenhouse gases, is the dominant cause. I think we should note the scientific near consensus, let's put it that way, that this is very likely or extremely likely to be a cause, and then think about what that requires in terms of action. We could be wrong, of course. Any predictions about the future pretty much could be wrong, but we need to consider what are the costs if we ignore predictions like this, if it turns out not to be wrong. Obviously, if the prediction was extremely unlikely that there'd be human influence, we would take a different attitude to what we ought to do. But if what we're looking at is trying to say, well, these are what the consequences might be, and then we consider their expected value, to put it in consequential terms, which is the consequences discounted by their probability. If this is regarded as extremely likely, then we have to look at that in those terms. So here then are some predictions of what might happen. This is a document that's a couple of years old now, from the National Academy of Sciences and various other bodies. And they drew on a lot of the science, and they said in 2010, carbon dioxide is now at 390 parts per million, which means since it's steadily going up, it's probably around 391 or something like that, 392 by now. It'll be a little bit higher than that. And that's the highest level, they say, for 800,000 years. And it could be 2 to 3 times higher than that by the end of the century. So then you have this list of what they think are the likely temperature consequences of rises in carbon. And these are all done to 2/3 probability, 66 degrees probable is what they estimate. So there's more doubt about whether, in fact, this particular amount of carbon in the atmosphere leads to this particular temperature rise. But, as you say, they're saying that carbon could be 2 to 3 times higher by the end of the century. So 2 to 3 times higher on 390 means that you could well be looking at this highest level if nothing dramatic is done about this, the assumption is. And these temperature rises are very extreme. As I said, we've had about 0.6 of a degree Celsius temperature rise over the 20th century to now, and it's already having observable consequences. It seems already to be having a variety of different consequences. As I said, it seems to be a factor in more extreme weather events, in more extreme heat waves in particular, in generally milder winters, although there's always local variations, but it does seem to be changing the climate. If 0.6 of a degree is going to do that, then obviously these figures are going to do much more than that, much more dramatic changes. The 2 degrees Celsius figure is sometimes used as you'll see in a moment, as a kind of a maximum that we ought not to exceed if we don't want to have really unpredictable and possibly catastrophic changes in the climate of our planet. Let's look at one very extreme prediction. This is an article published in the Proceedings of the National Academy, which says, how bad could things really get? Now, as you see here, it's talking about warning more than the 840 parts per million, more than the 5 degrees Celsius. So this is not something that's likely to happen in this current century, but it's not impossible that it could. And one scenario that makes it possible is that a certain degree of warming could produce feedback loops that lead to more warming. So one of the things that has been mentioned in this connection is the decline in ice over the Arctic. And so ice reflects sunlight. So if you have a lot of ice and the sun shines on it, a lot of that heat, warmth is reflected back into the atmosphere. But if the ice melts, you have the dark ocean, which absorbs more of the heat from the sun. So even if there were no further greenhouse gases going into the atmosphere, you could have warming as a result of the fact that that ice has melted, therefore the ocean gets warmer, therefore more ice melts. Another feedback loop that's been suggested is the release of trapped methane in the permafrost regions of Siberia, very large geographical areas that have been permanently frozen and that contain methane among the gases trapped in the ice or the frozen earth. That's thawing in places as the earth gets warmer. The southernmost boundary of the permafrost is pushing back north, and that may release very large quantities of methane, which again could contribute to more extreme warming. So these scenarios, although they're very extreme, are worth noting in terms of how bad could things really get. So these Sherwood and Huber say, at 7 degrees Celsius, some areas, small zones, would become impossible for human habitation. And if it goes further, that could be most of the areas in which people now live. Presumably other areas closer to the pole would become more suitable for habitation, but not enough of it to make up for the areas we lose. So those are some of the more dire predictions. But I'm going to focus mostly on the ones that are more likely to happen within the present century. Now, what are we doing about this? What have we said we are going to do about this situation? We can go back more than 20 years to the Earth Summit in Rio de Janeiro, where pretty much all of the world's nations, including the United States, agreed to stabilise greenhouse gases. And the phrase used was at a low enough level to prevent dangerous anthropogenic interference with the climate system. So that was something that they agreed to do, but they didn't actually specify how they were going to do it. And this was had no legally binding provisions in it. This level people have talked about this level, and that 2 degrees Celsius rise in temperature is, a lot of people think, is the point at which we would have gone beyond that level that's referred to. In other words, we would have not stabilised gases to prevent dangerous anthropogenic interference. But if we get to 2 degrees, that's what we're likely to have. So that sets a standard, sets a level. Now, some nations are not satisfied with that. At the Copenhagen meeting that they had a couple of years ago, in particular, the leaders of low-lying Pacific islands, small nations like Kiribati and Tuvalu and the Maldives, said that trying to reduce warming to 2 degrees Celsius was not enough because it would create sea level rise at a level that would mean that their low-lying islands would be inundated with seawater. So they argued that we should be more ambitious. We should try to restrict global warming to 1.5 degrees Celsius. But they didn't really carry the day on that, probably because a lot of scientists think it's virtually impossible to do that now, that the amount of greenhouse gases already in the atmosphere and the amount of warming that's already going on will take us past 1.5 degrees Celsius, and there's no realistic way of reducing greenhouse gases fast enough to keep us below that point. Another important conclusion that this Rio summit reached, or a phrase that was in the declaration, was that they recognised the right of developing countries to continue to develop. So essentially, this recognises a kind of two conflicting claims. On the one hand, yes, we want to stabilise greenhouse gases at a level to prevent dangerous anthropogenic climate change. On the other hand, developing countries have a right to develop in order to be able to help their people to escape poverty. And the problem, of course, is that these two things may conflict. If developing countries continue to develop using the cheapest available fuels, which are fossil fuels, coal in particular, then they're going to release more greenhouse gases into the atmosphere. So the idea set up a kind of two-stage process in which the developed countries were supposed to take the lead in terms of reducing greenhouse gases, and at some later stage, the developing countries would be brought into this. So the initial constraints were on the developed countries rather than the developing countries, recognising the greater needs of developing countries to develop. So this is essentially what I've just said, that the rights of states to sustainable development. But the phrase sustainable development here is very vague, and some people would say, well, if you're going to use fossil fuels to develop, then that's not sustainable. But the notion of differentiated responsibilities mentioned here is what makes the difference in how the countries should go ahead.